Let's talk about Ensemble learning a little bit more. We have covered this a little bit already, but there is more than one way to do that. So I just wanna cover some of the basic techniques that exist for Ensemble learning. In case of random forest, it kind of an important topic, but it will be a short lecture because the ideas are pretty basics here. And remember, random forest, we had a bunch of decision trees in random forest that were using different samples of the input data, subsamples, and different sets of attributes that it would branch on, and they all voted on the final result when you were trying to classify something at the end. That's an example of Ansible learning. Another example, when we were talking about k-means clustering, we had the idea of maybe using different k-means models, that different initial random centroids, and letting them all vote on the final result as well. Also an example of Ansible learning. Basically the idea is that you have more than one model, and it might be the same kind of models, might be different, but you run them all on your set of training data and they all vote on the final result for whatever it is you are trying to predict. And oftentimes you will find that and different models produce the better results than by any single model could on its own. A good example from a few years ago was the Netflix prize. Netflix can run a contest where they offered, I think it was $1 million to any researchers who could outperform their existing movie recommendation algorithm, and the ones that won were the Ensemble approach, where they actually ran multiple recommender algorithms at once and let them all vote on the final result. So Ensemble learning can be very powerful yet simple tool for increasing the quality of your final result in machine learning. Now random forest again used a technique called bagging, which is short for bootstrap aggregating, which is yet another fancy term for a sample concept. All it means is that we took random subsamples of our training data and fed them into different versions of the same model, so let them all vote on the final result. So if you are remember, random forest took many different decision trees that use the different random samples of the training data to train on, and then they all came together in the end to vote on a final result. Okay, so that's bagging. Boosting is an alternate method, and the idea there is that you start with a model, but each subsequent model boosts the attributes that address the areas that are misclassified by the previous model. So you run train test on the model, you figure out what are the attributes that it's basically getting wrong, and then you boost those attributes in a subsequent manner in hopes that those subsequent models will pay more attention to them and get them right. So that's the general idea behind boosting. You run a model, figure out its weak points, amplify the focus on those weak points as you go, and keep building more and more models that keep refining that model based on the weaknesses of the previous one. Another technique, and this is kind of what the Netflix prize winner was called, a bucket of models, where you might have entirely different models that try to predict something. Maybe I am using k-means and a decision tree and regression. I can run all three of these models together on a set of training data and let them all vote on the final classification that I am trying to predict something. Maybe that would be better than using any one of those models in isolation. Okay, stacking, same idea. You run multiple models on the data, combine the result together somehow. The subtle difference there between bucket of models and stacking. Bucket of models, you basically pick the model that wins, so you run train test. So you find the model that works best for your data and you use that models, whereas stacking will combine the result of all those models together to arrive at a final result. Now there is a whole field of research on ensemble learning that tries to find the optimal ways of doing ensemble learning. And if you want to sound smart, usually that involves using the word base a lot, which you will see on this slide. There are some very advanced methods of doing ensemble learning, but all of them have a weak points, and I think this is a yet another lesson that you should always use the simple technique that works well for you. So these are all very complicated techniques that I can't really get into in the scope of this course, but at the end of the day it's hard to outperform just simple techniques that we have already talked about. So in theory there's something called the Bayes optimal classifier that will always be the best, but it's impractical. It's computationally prohibitive to do it. People have tried to do variations of the Bayes optimal classifier to make it more practical, like Bayesian parameter averaging, but it's still susceptible to overfitting, and it is often outperformed by Bayesian, which is the same idea behind random forest. You just reassemble the data multiple times, run different models, and let them all vote on the final result. Turns out that works just, and it's a heck of a lot simpler. Finally, there is something called Bayesian model combination that try to solve all of the shortcomings of Bayes optimal classifier and Bayesian parameter averaging. But at the end of the day, it does not do much better than just cross-validating against the combinations of models. Stacking basically, so again these are very complex techniques that are very difficult to use in practice. You are better off with the simpler detail that we have talked about. But if you want to sound smart and use the word Bayes a lot,